Alright folks, welcome back. I feel much better. I feel extremely better than I did in the last video. So the last video I expressed some concern about the way the topology was laid out, more so with the devices themselves, not so much the design. I know the design's good, it was just behaving wrong. So I changed a couple versions of code, and I also replaced devices with those old layer 2 switches with actual 8 kVs. So the newest, Cisco 8000V Catalyst router that essentially is modern and not legacy. So I feel way better about that. So I got the topology back the way it's supposed to. So I just want to kind of point out a few things. We'll get connected to some of these devices and we'll go through some verification just to make sure that we are all on the same page. Let me close all of this stuff and just kind of open things fresh. Okay, so this is the firewall. All right, so if we take a peek at the firewall kind of is the boundary between the private segments and the public segments. Okay, so this is kind of where we left off in 2-3 videos ago, whenever it was. So it has gig 1 and gig 2 have connections up to the edge switches, which, remember, they're just transparent layer 2 switches that are going to provide VLANs to internet connections and our internet routers. There's really no, I don't want to say there's no routing on the switches themselves. Obviously there's routing going across the VLAN cables and all that jazz, but there's no routing on the switches themselves. Versus the cores actually have default gateways, HSRP instances. There's actual routing happening, or there will be routing happening on those devices. So the 3 and the 4 that go down to the cores, they have their own, that's a virtual port channel going down to the cores. And again, that's where that private IP address range starts to come into play, as opposed to 1 and 2, which is a VPC, but that's where it's going to be that NAT boundary that we kind of talk about. So let's just, we'll just go through it. So if we show IP interface brief, so remember, we're on an actual router this time. So show IP interface brief, we can see that our interfaces 1 through 4 are all up. Okay, so that was the 4 interfaces I just explained. 1 and 2, when we look at the running configs for 1 and 2, they should belong to their own port channel. Okay. Okay, so 1 and 2 are part of channel group 2, and you can see now I can actually do this the right way. On the router, I can specify LACP. That's what the active means, right? Active passive is LACP. We don't want to just run on, which is what the only format that some of the other boxes were capable of doing, and I did not want to do it that way. I want it to stay industry standard, which is LACP. So the command to verify the port channels is similar to a legacy switch. It's show ether channel summary. So when I show ether channel summary, I can see that the port channel 2 that we were just describing it's routed and up, it's using LACP, and it has gig 1 and 2 bundled, and it's happy. Okay, so that's our port channel as far as the firewall that goes up to the edge switches. Let's look at what the edge switches have. Let's look at the other side of that configuration from their perspective. So if we show run interface E13, we can see that that's our link to the firewall. It is a trunk, and it's in channel group 3 mode active. Okay, we should see the same exact thing on edge 2. So description DC1 firewall 01 switch port mode trunk channel group 3 mode active. If we show port channel summary, we're only really talking about port channel 3 at the moment, so let's just hone in on him. So we can see that he switched up LACP, and 1.3 is essentially, up in a port channel. He's bundled. We should see the same exact thing on Edge 01, which we do, so that's good. And then last but not least, if we show run interface port channel 3, the addition that we need to make is it's a VPC, right? Because it's going to one device, and we're trying to fake that device out into thinking that it's connected to one switch, when in reality it's connected to two switches. So VPC3, we should see the same thing on Edge 02. Okay, switch port mode trunk, and he's in VPC3. Now the final command that we need to run is show VPC. So we want to see that VPC3 is leveraging port channel 3. It's up, everything's successful, and we haven't done any VLANs. I'm not going too far. I'm just trying to get the VPC functionality working, which has been the headache for the last 12 hours. So all this is in play. It looks great. Let's just verify the other side. Okay, so you can see that port channel 3 is up and everything is happy. Okay, so that's the virtual port channel between the edge switches and the firewall. Let's just really quickly, just so you guys can see, we'll look at the VPC between the firewall going down to the cores. Okay, so back on the firewall, that's interfaces 3 and 4. So we already know that, through process of elimination, and we're staring at it right here actually. So port channel 1 is what's configured to use 3 and 4. It is the same exact configuration that we just looked at for 1 and 2. So if we show run interface gig 3 and 4, there's nothing more than channel group 1 active, and then when we look at the port channel itself, it's literally just up. Okay, like we just enabled it so that we can bundle those interfaces. So remember, this is a router, not a switch, and we're not doing VPC from its perspective. All right. If we show IP interface brief, we do have the sub interface, which is a beautiful thing. Before I get into that, I'll come back to that in 1 second. Let's just look at the cores. So core 1, core 2. All right. Show run interface E11. Let's put a description on him just so we can be thorough. We've got our alias for write, so we don't need to run copy run, type copy run start. Sorry, I'm looking at the wrong switch and typing the wrong thing. This should be 1 because I'm on core 2. So let's put a description on him as well. Okay, we'll save him. So if we show port channel summary, all right, we can see that we have 3 port channels. Port channel 1 is the VPC between the switches themselves. So that's what makes it the VPC peer. We defined the peer link. We did all that many videos ago. So that is still in play and that's still healthy. Port channel 2 is the one that is going up to the firewall. So we can see that it's LACP. It has 1.1. It's bundled in the port channel. The only difference on this one is we should see VPC defined under the port channel, which we do. Okay. So quick health check on core 2. So we see the same exact verification. Everything looks happy. Show run interface port channel 2. Like I said, VPC2. So let's do the final verification. Show VPC. We can see that port channel 2 is up. It's success, and it's happy. Okay. Show VPC. Up, success. So life is good. This is what we wanted before. This is what I couldn't make happen. Like I said, difference in code appears to have made a big difference. So that is that. Now, I said let's go back to the firewall to look at that sub interface. So if you remember, we were going to use the private subnets that we're carving out for this entire data center are 10.101.00/16. So that means we can use all of the VLANs I have listed in the key. Okay. 255, I had made mention, we're going to potentially use that for loopback interfaces across the devices. This can be for things like Simple Network Management Protocol, or SNMP, or, peerings between routers if we, when we start to bring protocols into play, and potentially even management, right? Like SSH, or maybe we're doing some kind of automation, right? And we need to be able to do Python scripts or Ansible or whatever. We can use those IPs for those types of things as well. So 255 is not assigned yet because we're not really there yet. But 254, the next one back, we decided we're going to use that for, let's say, like interconnections between devices. Okay. So VLAN 254 is defined on the core switches. So if we look at show VLAN, we have the servers 101 and the servers 102. Remember, they go down to the servers through top of rack switch 1. And then we have VLAN 254. All right. VLAN 254 has to live on both cores. Okay, so we see it there. And if we look at show IP interface brief, we have the same VLAN interface that we did for 101 and 102, and it takes into account the HSRP. So we saw this a couple videos ago. So if we do the show run for VLAN 254 on both cores, it's called the exit VLAN, kind of a lame term, but basically it's the VLAN that we're going to use to get up to the firewall and exit the data center. Like I said, it's kind of lame, but that's just what I called it. It's got .1 is the local address for core 1, so switch 1, right, gets the IP of .1. Switch 2 or core 2 gets the IP of 2 to make it easy. We'll come back to this. I was testing the routing function. The routing's not in play right now, believe it or not. I'll just take that stuff off. So let's take that off, and let's take that off, because we're going to do all this stuff together. I have trust issues with the lab, so I feel like I need to test things 4 and 5 steps in advance, unfortunately. So going back to the interface beyond 254, right? So local IPs, and then literally we just tie HSRP. So I had made mention there's no real reason to make the HSRP number or identifier different than the VLAN. It just makes it harder to keep track of things. So you might as well keep your VLANs, everything's in sync, so to speak, right? Preempt, both routers are going to have preempt. Only router 1 or core 1 gets priority 105. And then our virtual IP, we agreed we're going to make all the gateways end with 254. The track 2 decrement is basically the same logic we used for top of rack switch, but this is for the reverse path from the firewall going down. So the firewall has to have a route that points all of its 10 dot traffic. And again, we'll get more into routing later. But the firewall has a route that says anything that's 10 dot, okay, all the 10 dot addressing, I want you to send all of those packets to 10.101, 255, 254, 254, okay? And that address is the HSRP address that's shared between both cores. So the idea is that when the firewall needs to send traffic down, it sends it to the VIP, which is shared between the two devices. So if a device goes down or a link goes down, it will automatically still route packets down to the top of rack switches. So we want that resiliency. So that's what that does. And obviously this is the default gateway. If we need it for whatever reason to put that VLAN somewhere else, that's going to be the default gateway for any and all devices in that subnet. All right, so that is what has been corrected to this point. So I wanted to kind of go through that, express my happiness that it's actually working and it looks good. The next step will be these routers are the internet routers, right? And by the way, they look healthy. So we're going to configure all this stuff together. And on router 1, because he's off, I wanted to do a quick test to make sure I wasn't going to waste our time. But if we show ether channel summary, it is literally the same exact config that the firewall has, except these devices sit above the edge switches. Okay, so it's a lot of rinse and repeat here, and that's just because now we're in more of a layer 2 segment where we're going to be addressing the internet side of the house. So I'm going to stop here. I'm happier. I feel like we're in a good place. Hopefully that's the last roadblock here. So when we come back next time, we'll go over this config. We'll bring router 1 into the mix. We'll get those port channels working down to the edges. And then we should be able to start bringing in ISP connectivity into the data center. That is the other quick change I had made. So in order to make this look a bit more like the internet, in our case, we're going to have Internet Service Provider A, which will have him deliver a circuit which will come into Edge 01, but will be essentially on router 1. So router 1 is going to have his own internet connection through ISP A. Router 2 is going to have his own internet connection through ISP B. That is essentially just trunked through the switch, right? And that gives us 2 circuits spread across 2 routers through 2 edge switches for redundancy up and down the entire stack. I did a connection between the two. This would just be the internet, right? ISP to ISP. And then we'll put all of our testing loopbacks, like I had said before, 8888 and 4222, just well-known IPs. We could put whatever we want up there. It doesn't matter. But we'll do some BGP peerings between all 3 of these. We'll have 3 different autonomous system numbers, and we'll just get crazy with internet BGP routing and stuff, and we'll basically add some hops. So when we trace route, when we're all said and done, if this server does a trace route, we should be able to trace its steps through the network out the data center to the cloud all the way at the top with the internet loopbacks. That's the goal. And again, we're going to introduce NAT. And we can even do some traffic engineering so that if we want to favor ISP A over B, we can do that. Inbound or outbound, we can start to play with some of those BGP attributes and discuss some of that too. So again, I think we're at a good spot. I just wanted to share the good news, and we will pick up here next time, and we'll be really close to finishing the data center build out. So I look forward to seeing you guys there. Thanks.